doubt we are going to deal with. We will not go through basics of it, but we will be dealing with what are electrical quantities and how are they interrelated. Okay, so directly I will start with electric current, but yes, in between I will definitely include the basic concepts which are involved in that, like structure of atom, what are the charges, that also we will do. Okay, so see, first if we talk about electric current, okay, so electric current is, you can formulate it as I is equal to Q upon time. So here I we are denoting for electric current, Q for charged particles, and T is for time. Okay, so suppose if you have this kind of metallic rod, okay, we are taking this example. Now you know that why I have taken metallic rod, because these metals are said to be good conductor of electric current. Okay, so here this symbol we are taking for power supply, or you can say battery. Okay, so this one we are noting it as positive terminal, this is negative terminal. Now here we can show switch as well. So this is how this circuit is being made. This is the key. Okay, now understand, this metal is made up of atoms. Okay, metals are also made up of atoms only. You know structure of atom, what are the fundamental particles of atoms. So you know that there is positively charged nucleus. In this nucleus, this is nothing but it is positively charged proton. We are not talking about neutron because they don't have any charge. Okay, so this one you know very well, it is electron which is negatively charged and it is revolving around the nucleus. This much we know. Same way, in this metallic rod, there will be such kind of positive particles, okay, as well as negative particles. We will say electrons. We will say, okay. So these are the electrons, and they are said to be free electron, which means it can delocalize or it can move. So when this switch is on, what will happen? This all electrons will start moving, start flowing in one direction. Remember this, electrons are moving from negative terminal to positive terminal. Just to differentiate that, I am showing flow of electron is from negative to positive terminal. Okay, but conventionally we take flow of electric current is positive to negative. Whenever you are asked to draw the direction of electric current, you will be drawing positive terminal to negative. But in reality, electrons are flowing from negative to positive. Okay. So here, if you are asked to define electric current, so electric current is being defined as number of charge particles flowing in unit time through this conductor, or you can say it is the rate of flow of electrons, we call it charge particle, through the conductor. So here if you want to give unit, you know that charge will have unit coulomb, we denote it by symbol C, and time will have unit second, so we denote it by S. So, but in the honor of scientist Andre Ampere, we are giving unit ampere for electric current. So, how can we define 1 ampere? So, if 1 coulomb charge particle flows in 1 second through this conductor, we will say 1 ampere electric current is flowing through it. One more thing I will tell you, which instrument or device is used to measure the electric current. So here you will be using ammeter. Ammeter is the device which is used to measure electric current, and SI unit of electric current is ampere. Okay. So here one more thing you have to remember, this ammeter is always connected in series. This we will discuss in detail, what is series connection, what is parallel connection. Okay. So this is about electric current. Now next electrical quantity what we are going to do is potential difference. Just now I said these electrons are flowing from negative terminal to positive terminal, because of which electric current is generated. Now they are not going to do on their own. So some energy is required, some work is required. So amount of push or that pressure, or you can say amount of work which is being done to carry this charged particle from one point to infinity or one point to another point through this conductor is called potential difference, and we denote it by voltage. Children, now we are going to learn about Ohm's law. In Ohm's law, first of all, we will discuss what kind of instruments are used in this. Here we are going to use battery eliminator. Okay. Simply we can say power source or battery, key, rheostat or variable resistor, voltmeter, resistance, as well as ammeter. Okay. So these components will be joined together. Now we'll see how they are connected to each other. Okay. So first of all, what you need to understand here is this power source we are going to connect with this key. This key further we can connect with the rheostat or variable resistor. You can see this is the variable resistor in which this can slide, which is the slider or you can say jockey, which will be moving to change the different resistance. Okay. Now this we are going to connect further with resistance. This is the 10 ohm resistance. So this resistance is further connected with the ammeter, and this ammeter is connected to this battery element. So you can see here all these components, they are connected in a series connection, which means only one terminal is attached to one terminal of another one. Okay. But if you see this voltmeter, this voltmeter is connected parallel to this resistance. So you can see here both the terminals of this voltmeter is connected with this. So here we can say they are parallel to each other. Okay, so remember that whenever we use ammeter to measure the electric current, how much current it is flowing in the circuit, then it is always connected in series. While voltmeter, if you want to know how much potential difference is there between these two terminals of this resistance, we are using voltmeter or potential difference. Okay, so this is the entire circuit, how it is joined together in Ohm's law. Now, if you do this diagrammatic representation for this Ohm's law, you can design the circuit based on the symbol given to this instrument. First, this is battery, so we can take this symbol for battery. Okay. Now, this is for key. Since it is plugged in, so we will be drawing this kind of symbol which shows it is plugged in or circuit is complete. After that, you have variable resistor. So for that, you can draw this kind of symbol. But since you know that same way goes for resistance, so to show that it's variable resistor, you will be drawing this kind of arrows. Okay. Now to continue that, here further you have resistance. To draw the symbol for resistance we can this way is the resistance. Now this resistance further it is connected to the ammeter. You can see here ammeter is connected in series. So this is how you will complete it. Now one component is still missing. What is that? Voltmeter. But voltmeter is connected parallel. So this is the symbol for voltmeter. We are connecting it parallel to this. Okay, so this is how you can draw the circuit based on the given diagram. This is showing positive terminal, this is negative. This is how you can show the direction of electric current, okay, which is conventionally taken as positive to negative. So this is the diagrammatic representation of Ohm's law circuit. Now we will do what we have to learn in Ohm's law. Okay, in this case you need to understand we will be taking two variables into consideration. One is the electric current, what you will measure with the help of ammeter. Second is voltmeter, which will give us potential difference, and with the help of rheostat or variable resistance we can control the electric current. Okay, so suppose you start taking reading of voltage and potential difference. You can control either of this. If you want to control voltage or potential difference, that you can change with the help of this battery eliminator. Okay, this is variable battery also. Suppose we are taking electric current and voltage. Suppose we have here voltage 2 volt and electric current we are getting 0.1 ampere. Suppose if you increase it and the value coming for electric current is 0.2 ampere. Same way for 6 volt it is coming 0.3 ampere, and then for 8 volt you are getting 0.4 ampere. So this value we are getting. Okay. Now if we have to plot a graph for this, so what kind of graph you will get with this? So here we are plotting graph of V versus I in this. Okay. Suppose here we are taking electric current, here we take voltage. If we have electric current 0.1, for that we are taking voltage 2 volt, 4, 6, 8, same way 0.2, 0.3, 0.4. So for 0.1 it is 2, for 0.2 it is 4, for 0.3 it is 6, for 0.4 it is 8. So if you see this graph, it is coming straight line. So this is the straight line graph. Okay. Now from this graph, if you take a gradient, okay, suppose if you are taking gradient from this 0.2 ampere electric current, how much voltage you are getting? It is coming 4 volt. So if we take ratio of this, so V upon I over here is coming how much? Ratio will be coming how much? 4 divided by 0.2 will be giving you how much? 4 upon 2 into 10 the 4. So answer coming is 20. Okay, this is 20. If you take some other value, say for 6 volt, it is coming 0.3. Again, you will say here it is 8 volt and this is, sorry, we had taken 6. So this is 6 volt. For that we are taking 0.3. Again, you will be getting 20 only. If you see this V versus I graph, it is straight line and its ratio coming is fixed. So this shows that here potential difference V is directly proportional to I, which means if we increase voltage, current is also increasing. So if we remove this proportionality symbol, it will give you V is equal to R I, or you can say simply IR. And if you take ratio of V upon I, it is coming constant. So this R what we have taken is nothing but is constant value. And this is nothing but it is your value of resistance. Value of resistance. So how will we define resistance? Resistance you can define as the ratio of potential difference with respect to electric current. Okay, ratio of potential difference and electric current in a circuit will give you value of resistance. Okay, here SI unit of resistance we are taking ohm, which is denoted by this omega. Otherwise, for potential difference, it is volt. For electric current, it is ampere. If you have to define 1 ohm resistance, so you have to say if 1 volt potential difference is generating 1 ampere electric current in the circuit, so it will have how much? 1 ohm resistance. So this is all about Ohm's law. Okay, children, after this, now we will be learning about how different types of electric circuits are there. Okay, so first we can see series circuit and parallel circuit. In this, if you have series circuit, resistor, this is the symbol of resistance. This is another one. Suppose we are taking value of this one as R1 and this is the value of R2. If they are connected in series, you can see they are connected end to end, only one terminal is attached to it. Okay, so if we complete this circuit, this is the cell or battery. Here we are taking battery. Okay, this is the completed. Now, if voltage V is there with this battery and it is allowing flow of electric current I in the circuit. So what you have to remember here is in an electric current, so this is the series circuit. What you have to remember in series circuit, electric current is going to remain same at each resistor, but voltage is going to be different at each different. This we are taking V1, this is V2 because it will be different, but electric current is going to remain same. So if you see total voltage V is going to be equal to V1 plus V2, which is nothing but the addition of both of this potential difference, which will be equivalent to amount of potential difference provided by this power supply. Now, according to Ohm's law, what we had discussed, V is equal to IR. This is what we have learned here. Okay. So now, in place of V, if I put IR, instead of V1, I will put IR1. Why? Because electric current is same. Same way, V2 will be IR2. Now, I is common in both of them. So, IR is equal to IR1. Okay. In place of this, what we can do if we take out this I common will be I into R1 plus R2. So, this I will get cancelled with this, okay, because it is both the side same. So, here formula for equivalent resistance or total resistance in a series circuit will be equal to just simple addition of all of these resistors. So R is equal to R1 plus R2. This happens in a series circuit. Okay. Now children, we will discuss about parallel circuit. So in a parallel circuit, here also we are taking two resistors which are connected parallel. This is one, this is another one. We can complete the symbol first. So this is resistor 1, R1. This is resistance R2. Okay. Now, as I said, they are connected in parallel. So both of their terminals are going to be attached. Okay. Here, both the terminals are attached now. We will give power supply. These are the parallel circuit. Okay, positive. Suppose here voltage V is there and electric current I is flowing. Okay, electric current I. Remember, whatever electric current starts, that same electric current is going to end. But when it goes inside the circuit, for each resistor, it will have different electric current. For example, for R1, I am taking electric current I1. For R2, we are taking I2. But remember, potential difference is going to remain same in both the cases. So here, total current, electric current I is equal to I1 plus. Now again, according to Ohm's law, see here, according to Ohm's law, V is equal to IR. So I is equal to, I can write it again here, V is equal to IR. So I is equal to V upon R. So this is how we can formulate this. Okay. Now we will substitute this value. So instead of I can put V upon R. I1, we can put V by R1. Why? Because potential difference is same in R1 as well as R2. Same way here, V upon. Now, V upon R. Here, from here we can take out V common. It is 1 by R1 plus 1 by. This V will get cancelled with this. So, V1 is a V. So, equivalent resistance here 1 upon R is equal to 1 by R1 plus 1 upon R2. So, this we have to remember here. But remember, this is not the equivalent resistance. This is reciprocal of equivalent resistance, which is equal to addition of reciprocal of each resistor. Okay. So, this we have to remember. If you have to find out the equivalent resistance, what you will do? You will simplify this. 1 upon R will be equal to, you will take LCM. So, it will become R1 plus R2. So, LCM, it will multiply here R1 into R2. If you take reciprocal now, so R will be equal to R1 into R2 upon R1. So, this is how equivalent resistance you find in a parallel circuit. Okay. So, now children, for this, it will be better if we take few examples. Simple example we will take. Suppose in this parallel circuit, okay, this is the parallel circuit. Here, resistor 1, resistor 2. Suppose this is 2 ohm and this is 3 ohm resistance. It is connected parallel. Here also, join this, treating the circuit with power supply, positive. Suppose here we have to find out equivalent resistance in both. So this is going to be equal to, according to our formula, 1 upon R. This one we will follow every time. It is better you follow this. This is for your understanding. 1 upon r is equal to 1 upon 2 plus 1 upon 3. You will take LCM. LCM coming is 2 into 3, 6. So 1 upon r equal to, here you will multiply with 3 to make their denominator 6, 3, 3. Here you will multiply with 2. So 3 times 1 is 3, 2 times 1 is 2 upon 3 twos are 6. So here 1 upon r equal to 5 upon 6. Okay. But this is not the final answer. Your resistance, equivalent resistance R will be equal to 6 upon 5. When you simplify that, you will be getting it as 1.2 ohm. So this is your final answer. This is how you will calculate when circuit given is in parallel. Okay. Okay. So if it is in series, then how will you do that? We will be taking same values of resistance. Suppose this is resistor R1, which is 2 ohm. This is resistor R2, which is 3 ohm. Completing the circuit, taking cell over here. Positive. So what will be equivalent resistance in series circuit? So here you just need to simply add them. 2 plus 3 is equal to 5. Okay. So this is how series and parallel connection takes place. Okay. Now, children, after this, we will be doing power. Okay. What do you mean by power? So, power is rate of doing work, which means work upon time. Here, when we started, we discuss about electrical quantities, wherein I is equal to Q upon T, or time, so charge upon time. And here power we have taken W upon T. Here W is work. This is work. Now we know that potential difference V is equal to W upon Q. This also we discussed. So here also it is nothing but the work. Okay. Now if I subject this work, so W will be equal to V into Q. In place of this work, if I substitute V into Q, it is going to be V multiplied by Q and the whole upon T. You can see here, what is this? Q upon T, which can be substituted with I. So power is equal to V into, so this is how you can derive formula for power. Other than this, you know that energy, okay? Energy you can find out, you know that work and energy, they are interchangeable. Why so? Because how do we define energy? Energy is nothing but ability to do work. Okay, so it is ability to do work, and we know that what is this work? Power is equal to work upon time. If you substitute work over here, this time will be going on this side and it will multiply with that. So work or energy is equal to power into time. Better way, we can write E is equal to power into time. Okay. Now, where do we use this? So remember, whenever current is passing through any resistance, it is heating, it is generating heat. So how much heat is generated, that you can find out with this, how much power and for what time you are supplying it. Okay. Now if you substitute the value of power over here, or you can say V into I, if you substitute, so energy is equal to V into I into T. So this is used when you are given time, electric current and voltage. Okay. Or else if you are given V into I, or voltage and current, you can find out power and multiply with time. Okay. Further also you can do substitution, like energy is equal to V is equal to IR, we know that. How come? According to Ohm's law, V is equal to IR. This we already know. So we are substituting that only into I into T. So this becomes energy is equal to I square R T. Okay. Same way, in place of I, you can put V upon R. E is equal to V into, in place of I, if you subject this, V upon R to T. So energy will be equal to V square upon R to. So this is how different derivations can be done, but based on the quantities given to you, you will find the answer. Okay. Can we take one example for this? Yes. See, if you are applying current I, which is 20 ampere for time 10 second with voltage 220 volt. So how much energy is generated? It may be further asked as what kind of or how much power will be there. So power is equal to V into I, which is 220 into 20 you can do here. So power you will be getting here, it is around 4400. Now one more thing, what is SI unit of power? Is watt. So we are putting it as, okay. Now once you know power, if you are asked to find out energy, how much energy? So power into time. So power was 4400 multiplied by time, which is 10 seconds. So that is going to be how much energy? Is 44,000. Now what will be SI unit of energy? You will write joule. Okay, SI unit of energy we are taking as joule. So this is about electricity. Okay.